Circle theorems, one of the best topics at GCSE. Let's take a look at two cool examples and apply the circle theorems and explain our reasonings for using them. Now there's 7 or 8 that we need to know for our GCSEs. I'm just going to speed run them by just drawing them very quickly. So the first one is angles in a semicircle are 90 degrees. Very similarly, I'm going to prove these two, by the way, in a future video, is the arrowhead. So I'm going to narrate them for you. So angles in a semicircle are 90 degrees. It doesn't matter where I did them. The next one is angle at the circumference is half angle at the center. Yeah, or angle at the center is double angle at the circumference. The next one, we could talk about this one. Opposite angles in a cyclic quadrilateral add up to 180. Okay. Another one is tangent meets radius at 90 degrees. Okay, so I'm saying them. You guys feel free to write them down. The next one is angles in the same segment are equal. See how I didn't take my pen off the page? Bang, 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 bang. Yeah, so angles in the same segment are equal. What is that? 4. Then we've got, what have we got? We got the lengths of tangent from a common point. So the lengths of tangents to a circle from a common point are equal in length. Okay. What else have we got? We got a fan favorite is the alternate segment theorem. The alternate segment theorem is the angle between a tangent and a chord. So the angle between a tangent and a chord, if you take that chord and draw a line to the circumference, or lines to the circumference, they're the same. And I think that's it. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yeah, I think that's it. I don't think I am missing any personally. Cool. Let's use any of those in the following questions. If I remember one of them, I'll be sure to write it down. But I think that's it. Okay, so we have this triangle here. You could say radius is of constant width. So I don't know. I wouldn't say this is a circle theorem, but that one, radius of constant width, that one's a good one because I guess you're saying that you're always going to form an isosceles triangle, right? So here we have this situation. We have A, B on the circumference. Here we have the center O. We have CD being a tangent. So I'm really thinking about, you know, these kind of ones, yeah, if applicable. So work out the angle CAB. CAB. All right, this one. Okay, let's call that X. All right, well, that is an angle between a tangent and a chord. Yeah, so we could be using this. However, I don't see from there lines that go to the circumference. You could make one, but don't mess up your diagram. It's not needed. All right, they would usually include that for you at GCSE if they did want you to use the alternate segment theorem. So I'm gonna say no to this one for now. So I'm thinking about maybe these ones, the angle tangent meets radius at 90 degrees, and maybe this one, but I don't see two tangents. So probably we're going to be using this one, this 90 degrees. That makes sense. Okay, so always make a plan with these circle theorems. So we could say OAC is 90 degrees. I'm not going to write it down, guys, but tangent meets radius at 90 degrees. That's what you write down in the exam. Okay, that's a C, not an E. Okay, so it means that if that's 90, if I know what this angle is, then I can just do 90 minus that and then I'm done. Okay, well, this is 90 degrees. We can do angles in a triangle to work out this angle here. So we're going to say AOD is 180, take away 90 degrees, take away 42 degrees, which is what? 48. 48, wait, 48 degrees? 9 minus 4, why am I bugging? Yeah, 48. Ayo, let's skip that. So that's 48 degrees. Now, we can work out this angle here. So this, I would say, angles in a triangle add up to 180 degrees. I would over-explain everything in the exam, especially if it's a 4 or 5 mark question. Now I'm going to do 180 minus 48, which is what? 132. 132 degrees. So that's 132. And that's angles on a straight line add up to 180 degrees. This is BOA. Then we know that here we have an isosceles triangle. So I'm going to say OAB. Triangle OAB is isosceles, since OB is OA, are the radii, or the radii. That's technically a circle theorem in itself. So we're going to say BAO, therefore BAO. What? BAO is 180 minus 132, which you already know is 48, divided by 2, which would then be 24. Therefore, our answer of, what is it? CAB, do they want CAB? Is 90 degrees minus 24 degrees, which is, let's just remove that, 66 degrees. There we go. Okay? Over-explain everything in the exam. Last one says, we have this tangent. The size of angle BAD, where's BAD? BAD, so this angle here, is 3 times bigger than the size of angle BCD, which is this. Yeah? So BAD is 3 times bigger than this. So if I call this x, this would be 3x. Find SBA. SBA, find this angle. Now technically, in the question, they have not said show your working or give reasons for your answers. So in the exam, guys, you don't need to say anything. I'm going to tell you what I'm using, but you don't need to write it down. So if I just call this y because I've used x and 3x, I can see a quadrilateral. So in the exam, they would describe it to you. They would say A, B, C, and D are points on the circumference. So here we have a cyclic quadrilateral. The opposite lengths of a cyclic quadrilateral add up to 180. So 3x plus x is 4x is 180 degrees. Dividing both sides by 4. Half that 90, half that again 45 degrees. Okay. Now, I'm again thinking, so that's obviously given in the question. That's why it's the first thing we dealt with. I do have a tangent and a chord. Okay, I actually have a chord here. Y is an angle between this chord, AB, and the tangent. So we could be thinking about this. But the only problem is that this chord doesn't go anywhere. Okay, there's no lines being subtended from this chord AB. However, there is a larger angle here that includes y and 20, which is tangent chord, and this chord does go over here. That angle x is equal to this big angle here. So that angle goes to this. We can use the alternate segment theorem. So y plus 20, this angle is just the same as x. Y plus 20 is just equal to x. That's using our alternate segment theorem. Remember, x is 45 degrees. Subtract 20, y is 25 degrees. And that's how we do that one. So guys, that's circle theorems. Obviously, we can apply all these theorems in many different situations. So yeah, if you want to see more circle theorems, let me know. If you did learn something, hit the like button. I'd really appreciate it. Subscribe for more maths content. If you're interested in my full GCSE maths courses, then more details in the description. And feel free to join the Lone Gang community on Reddit if you want to submit your own questions and get feedback from the maths community. See you in the next video. Nice.